Welcome to aminacademy.com. Let us do in hyperbolic functions a relation between hyperbolic functions continuation. Here now third relation we will do cos h squared plus sin h squared x equal, we know that cos h squared already proved is 1 by 4 e power x plus e power minus x the square. This 1 by 4 you can keep it out because it's a common for both, plus sin squared hx equal e power x minus e power minus x the square. Now 1 by 4 e power x square is e power 2x plus 2ab, 2 into e power x and e power minus x is 2 plus e power minus 2x plus here e power 2x minus 2 plus e power minus 2x equal 1 by 4 e power 2x e power 2x is 2 e power 2x 2 and 2 cut plus 2 e power minus 2x, then which gives to come out 2 by 4 is half e power 2x plus e power minus 2x, which is equal cos h2x cos h2x. That means we proved one more identity, cos h squared x plus sin h squared x equal cos h2x. Now similarly we'll prove this series for sin hx and cos hx. For and cos hx, we know that e power x is 1 plus x plus x squared by 2 factorial plus x cubed by 3 factorial x4 4 by 4 factorial, like that. Same e power minus x, instead of x we substitute minus x, 1 minus x whole squared is plus x squared by 2 factorial minus x cubed by 3 factorial plus x4 4 by 4 factorial. Now here let it be 1 and 2. Now subtracting 1 minus 2, which gives e power x minus e power minus x equal, here these alternatives are cuts here, x minus x cut and here x cube and x cube cut. Here we can say it is 2 times 1, that x cut. Next is x square by 2 factorial here subtracting means 1 minus 1 cut x, and x plus x is 2x, that is x because 2 out. Next is x square by 2 factorial minus x square by 2 factorial is cut. X cube by 2 3 factorial minus of minus plus, that is 2 out, x cube by 3 factorial, and x power 4 cut, then plus x power 5 by 5 factorial. Like that it is up to infinite. Now suppose if we add 1 plus 2, we get e power x plus e power minus x. Same like here, addition becomes this first term cancel, 1 minus 1 is cancel. Addition is 1 plus 1 is 2, so it becomes 1. Here x term cancel because x minus x is 0. X square plus x square over 2 factorial plus x square over 2 factorial is x square over 2 factorial, like x power 4 by 4 factorial. This is e power x plus e power minus x. From that we can say cos hx equal, because here e power x plus e power minus x divided by 2 is cos hx, so we can write cos hx equal to 1 plus x squared by 2 factorial x squared by x power 4 by 4 factorial x power 6 by 6 factorial infinite times. Now like that we can see same for sin hx. Also you can write sin hx equal, this one you can do because e power x minus e power minus x by 2 is sin hx, which is equal x plus x cube by 3 factorial plus x power 5 by 5 factorial, like that it is. Therefore next one, now we will find the relation between normal trigonometric function and hyperbolic function. Relation between trigonometric function and hyperbolic function. That means, look at here, we know that cos theta equal e power I theta plus e power minus I theta by 2, and sin theta equals e power I theta minus e power minus I theta by 2. put theta equal to Ix. From that, we can write cos theta is cos of Ix equal e power x, because I theta is e power Ix, theta equal to Ix. Here theta equal to Ix, here I theta is I squared x, I squared is minus 1 minus x plus e power x over 2, which is equal e power minus x plus e power x by 2 is cos of hx. Similarly, sine of sin ix equal sin ix, we know that e power minus x, e power minus x minus e power x over 2 like that we are putting theta equal to Ix. From that we can get it, which is equal, that is I e power Ix equal e power Ix is regarding that you can write e power minus x e power x by 2I, which is equal I square we need here put I squared into we can get it I square of sin hx by I, which is further equal I sin hx. That means we are getting like that tan ix equal e power I theta minus e power minus I theta over 2, which is equal I sin theta. There, like I tan theta, sorry, I. Similarly, you can get the relation tan of Ix equal tan of I theta Ix equal to tan theta. Tan Ix equal that means tan Ix equal sin Ix by cos Ix. Sin Ix is I tan I sin hx over cos is cos hx, which is equal I tan therefore tan Ix equal to I tan hx. Now we have the relation. Similarly, you can write the relations in collectively sin Ix equal I sin hx cos ix cos is equal to cos ix cos hx tan ix tan ix I tan x. This is the result of basic hyperbolic functions. If you have done, please subscribe our YouTube channel.